Okay, thank you everyone for joining us for our second part in our 4-part series today. And today we are going to be talking about sustainability, key drivers, the carbon calculations, and return of investment. Hopefully those that joined us in the first session, you would have noticed that we had a panel discussion. We were speaking at a high level from an organizational point and trying to really understand, like, what does sustainability mean to everyone? And what we're going to do in these 4-part series, we're going to start peeling it layer by layer. And today's session, we're going to focus on the project stages and how we can apply LCA and some of the key outcomes from that. So today you have me, Shivani Soni, head of Impact and Innovation, who oversees our co-innovation lab. And we're also joined by our amazing Samuel Boswell as well, who is our LCA consultant supporting us underneath the co-innovation lab as well.
Hi, everyone.
Good. So before we start and dive into today's discussion, we'd like to give you a brief overview of Symetri and our key mission when it comes around sustainability, so that we can get quickly to the real topic of today's discussion. So as Symetri, we are dedicated to driving sustainability in the industry. We focus on decarbonisation through our technology and expert consulting services. We're dedicated to helping our customers to reduce their environmental footprint and meet their sustainability goals on projects. Our goal is to make a positive impact by leveraging our solutions and expertise to contribute to a more sustainable future. And to be honest, one of the reasons why we focus so heavily on sustainability, well, climate change is causing a widespread negative impact globally. With more frequent heat waves, droughts, wildfires, and storms, these extreme weather events affects our communities, ecosystems, and our food security. And actually, they're leading to a biodiversity loss. And it's forcing some people to actually relocate due to rising sea levels. And for all of us working in the built environment, these challenges actually directly impact how we plan, design, and build. The urgency is clear. Action is needed now. And when we start looking at the construction industry, well, actually, we play a huge role in the global carbon emission and resource consumption. Sustainable construction is about minimizing our environmental impact by using recycled materials, and energy efficient methods, and reducing waste as well. We can lower our emission and create a more better outcome for our projects. And it's also important to address that embodied carbon is about 11% of the global emissions are tied to materials and building processes as well. And with that in mind, we as Symetri, we're committed to sustainability and that it reflects in our actions as well. And that means through collaborations with our partners such as Autodesk and One-Click LCA, we are working together to bring meaningful change to the industry. And one of our key initiatives is actually Naviate Zero, which is powered by One-Click LCA to enable users to get access to carbon impact earlier in the design. It's taking a proactive approach, data-driven approach to reduce emissions from the start. And then we also have our co-innovation lab, the driving force behind today's presentation, but it's focused around transparency, collaboration, and innovation. And these values are essential for effective decarbonization. So let's start today by looking at some of the key drivers that is actually driving sustainability in our industry. These are the forces that is pushing us to evolve and take meaningful actions. Our industry, as I mentioned, plays a major role in global carbon emission. Building and constructions are responsible for 37% of global emission. Governments are responding with stricter regulations, and clients and investors are even employees are demanding more sustainable practices. This is not just about compliance. Sustainability can also lead to cost reduction, increased efficiency, and by future-proofing your business for those that adopt sustainable practices early, there's also a clear competitive advantage as well. And as we start looking at some of these global policies that are driving these change, international initiatives like the Paris Agreement set ambitious targets for reducing our emissions. Governments are enforcing these stricter regulations and actually pushing for more greener practices. And although the numbers and the policies can seem quite overwhelming, well, the core principle remains consistent. It's reducing emissions and promoting sustainability. Regional regulations also allow for adjustments based on climate zones and making these policies a little bit more applicable worldwide as well. And the key to achieving sustainability, well, it's simply reduction over time. We need to focus on the three main areas: carbon emission, water usage, and energy consumption as well. The goal is clear: reduce energy use in buildings by 90% by 2030 and achieve carbon neutrality by 2050. Policies in the industry and industry declarations are guiding us towards these more ambitious targets, and it's actually helping us to drive more sustainable change across the built environment. And I'm just going to hand it over to Samuel, who's going to go through the project stages. But one of the key things that came out from our panel discussion last week was that actually a lot of our panelists and the audience were saying that they wanted to start decarbonization quite early on in their projects. It was key for us to start quite early on, but often it's sometimes not knowing exactly what we needed to do throughout the different project stages. What we're going to go through now is actually look at the project stages and some of the key outcomes that Samuel will talk about now.
Thank you, Shivani. Right, yes. Well, to start with, so understanding or having an understanding of the drivers of sustainability helps us take actionable steps towards carbon reduction. And so we'll dive into the specifics of how we calculate the carbon footprint throughout each stage of the project and what we can actually do with that information. And so we'll talk you through each stage of the project lifecycle, highlighting the key carbon analysis activities, their outcomes, and the benefits that they bring. So our goal is to show how carbon analysis not only helps us meet sustainability goals, but also adds value to your projects. So we'll start with the first stage, strategic definition and pre-concept. At this initial stage, we lay the groundwork for the entire project. So our primary focus is to secure investment and buy-in, and also by setting clear, tangible goals for both the project and its sustainability criteria. This involves establishing a strong business case and budget that highlight the financial and environmental benefits, setting ambitious yet achievable sustainability goals, defining the project's scope and the necessary information requirements, outlining our expectations for carbon performance and lifecycle considerations. And so by doing this early, we ensure that everyone is aligned from the start, but also we can achieve the maximum decarbonisation. So we can use benchmarking in this stage to establish a baseline for our design's carbon impact, but we can compare it against similar projects or industry standards to ensure that we're on track with our sustainability objectives. And so in this stage now, we dive a bit deeper into the understanding of site conditions. We can identify potential risks. And so the key activities include creating a detailed project brief, collecting comprehensive site information, allocating the budget and resources for conducting a whole life carbon assessment, engaging in design charrettes to brainstorm and integrate sustainable design strategies, incorporating active and passive strategies based on climate analysis to enhance energy efficiency. And so by incorporating these strategies, like those that respond to local climate, we improve energy efficiency and reduce the building's carbon emissions very early on. So conducting more than one LCA during a project or even during a specific design stage helps us to evaluate different options and choose the most sustainable route. At the concept design stage, we refine our strategies to further reduce the building's carbon footprint. And so these activities would include exploring various design concepts and material options to find the best combination for sustainability, making initial estimates of the building's size and usage to understand what the potential impacts could be, and also conducting early predictive life cycle assessments using generic global warming potential averages. And so this early analysis provides insights that can guide decisions for cost, but also sustainability and risk mitigation. During the spatial coordination stage, our focus shifts from refining design details to ensuring that they align with our carbon reduction goals. And so the key activities would be updating energy and carbon impact assessments based on the refined design, so any changes that may have taken place, engaging with the suppliers to gather detailed life cycle data for materials such as EPDs, replacing higher global warming potential materials with lower alternatives. And so this could be on maybe the building level or building elemental level, or the actual individual materials. These refined details ensure that we meet our reporting targets and also balance cost with environmental impacts. So by understanding these specification needs, we can maintain the design intent while also optimizing the sustainability of our building. And this stage also allows, or this is a good stage at which we can evaluate the opportunity cost of different designs, but also material choices, which I'll show a bit more about later, factoring in their life cycle cost analysis. So over their whole lifespan, this can also be compared against their life cycle carbon impact, and so allows us to make the most suitable decision for sustainability and cost. In this stage, we finalize the technical aspects of the project. And so these activities are producing detailed technical drawings that reflect the project's design intent, conducting accurate LCAs in coordination with accredited professionals, finalizing specifications to ensure they optimize material choices and meet the carbon reduction goals that have been set. These steps minimize the need for construction administration and quality control adjustment, streamlining the submittal review process. And so we can have accurate and detailed documentation at this stage, which is crucial for maintaining the project integrity and also achieving and justifying the sustainable objectives. Once we complete an LCA, we perform a hotspot analysis. So this can actually be done at pretty much any stage of the project. And of course, understanding this information as early as possible is always going to give you the greatest advantage or the greatest scope to actually implement any kind of changes that you might see worth doing. And so this helps us identify areas of the building or life cycle that have the greatest carbon impact, and allowing us to target and improve them. And so as we move on to the construction phase, it's vital that the materials used align with our sustainability goals. And so key activities at this point include procuring the materials that meet our specified criteria for low carbon impact, beginning the as-built LCA to capture accurate data on the materials and the processes used, and then ensuring thorough and easy reporting of the LCA data. So by doing so, we achieve the most complete and accurate life cycle assessment, facilitating easy acquisition of energy and carbon credits. And this transparency and accuracy in reporting enhances the project's accountability, but also confidence within all the various different stakeholders. So this is an alternative kind of view or way in which you can look at the cost carbon trade-offs. So you can also, at the same time, by looking at the specific impacts of products, overlay the cost in a sense. And so as we see here from this chart, we have 8 different structural steel profiles. The bars are listing the amount of embodied carbon that I think 10 kilograms of each of them are producing. And then the line is showing what the cost is. So this sort of data allows you to have conversations with the stakeholders and anyone involved, saying, these are your options. Which one do you think is the most appropriate to go with? At the handover stage, we ensure that the building is ready for occupancy and long-term sustainability. So the activities would include transferring as-built LCA data to the owner, connecting LCA data to the building's computerized maintenance management system, or CMMS, or facilities management system, FMS, and then also educating the owner about the building's sustainability features and maintenance requirements. So this comprehensive handover process is done to enable the owners to leverage the insights that have been gained up until now from our carbon analysis to prevent maintenance and long-term operational efficiency. It also ensures compliance with the LCA end-of-life scenarios or specifications, preparing the building for future sustainability. In the use phase, our focus shifts to more onto operational performance and planning for the building's futures. So these activities could be continuously tracking and monitoring the building's operational carbon footprint. This will, of course, give you the most accurate data on what the carbon footprint impact would be, making informed decisions for refurbishment based on the life cycle carbon insights previously gained, and planning for the building's end-of-life deconstruction to ensure materials again can be recycled and repurposed as they've been specified. And so these ongoing effects help to continuously reduce the carbon impacts, enhance the building's desirability, and potentially increase its market value. And by maintaining a focus on sustainability, we ensure that the building remains a valuable asset over its entire life cycle. And this is a very good graph as it illustrates the typical life cycle impacts of a building over its whole lifespan, with an initial spike coming from the materials. So this is what's highlighted in red. This is stages A1 to A3. But then also the ongoing operational energy use. So this is what's coming up as the bars that are in green. So you can see very, very large increase right at the start from the materials that are used. And so using an LCA, we can identify what contributes to these impacts and make informed decisions to reduce them. And now accurate data collection is very key to successful carbon tracking throughout the project. If you're gathering the right data, it allows us to make informed and sustainable decisions. And so some of the critical data points we focus on would be, or where we gain the information that we need to fill in the life cycle stages that are listed on this screen. Just to quickly clarify, this is the product stage, so essentially the materials that go into it, the construction, you've got the maintenance and use, which would be operational energy, and then the end of life stages. So this kind of data can come from bill of materials. And so, of course, a detailed list of all the materials, including the quantities and specifications. You've got the design documents. So this can be the architectural and engineer designs through drawings or whatever. You have supplier information. You've got material specification. So even environmental certifications or standards met by the materials. You've got construction schedules. So you can help estimate transportation impacts based on the material needs. And then we have operational energy models. And so the models can estimate the energy consumption, prior to the use phase, but also during the operation of the building. We can take direct measurements from that. And then there's the metering and monitoring, so systems that can track the water and energy use over the whole building's lifespan. At this stage, I'll hand it back to Shivani to summarize return on investment from doing life cycle assessments.
All right. Sweet. Thank you for that, Samuel. So as Samuel said, let's summarize some of the key opportunities that can come from our sustainability efforts throughout the project stages. So one of the key things, as we kind of mentioned in our last panel discussion, and as Samuel was kind of touching on as well, is starting to think early. And if we start to think early and we're putting that strategic thinking early in a project, it actually starts to lay a foundation for success throughout the life cycle. As this graph shows, that starting with sustainability in the concept phase, it actually allows us to have more cost control and a greater positive impact. It actually supports us in trying to delay these consideration and increasing cost as well. It also gives an opportunity to reduce significant changes. But as Samuel highlighted, acting at each stage, actually it opens up a wide range of benefits. When we start to revisit some of these major benefits of reducing carbon in the construction project, it can support us, such as looking at cost savings, looking at energy efficient practices that actually lead to lower energy cost. Second, it's actually looking at compliance. So it's about trying to stay ahead of the regulation. So it actually prevents legal risks as well. And third, it's actually meeting demands. Well, consumers and employees are prioritizing sustainability today. But fourth is giving us that competitive edge. Sustainable practices, it actually gives companies a clear market advantage as well. And fifth, it's like looking at investment opportunities. Sustainable projects actually attracts investors that are focused on climate conscious initiatives as well. And lastly is the supply chain resilience. Addressing climate impacts and strengthens the supply chain. Traditionally, in the past, companies had to choose between a financial success or social and environmental impacts. But now we can, and we must do both, actually. Technology allows us to track and optimize our environmental and social impact while actually capturing our return of investment as well. Collaboration and adaptation is key. Today's stakeholders actually value environmental and social objectives alongside the financial performance. By starting early with decarbonisation efforts, we're actually maximizing the potential for positive outcomes. The journey begins with action. Just as our panelists were saying during our last webinar last week, it's actually, we want to start early, but we also want to make sure that we can see what the balance is between doing the social good and the financial outcomes and the impact on it as well. And by using technology, it actually allows us to predict, track, and optimize both impact and the returns that we can get on our projects. In conclusion, the opportunities for sustainability in the AEC projects, they're actually quite vast. By strategically addressing the carbon footprint from early stages and leveraging technology, we can actually start to simplify what seems like quite a complex topic to actually achieve. And by doing them in the bite-sized chunks, as Samuel was kind of explaining earlier on, actually we start to address both of them. We start to achieve both environmental and financial success as well. All right. So on that note, I want to say thank you to everyone for joining us today, right? If you do want to find out more about what do we do as Symetri and how we can actually support, please kind of visit our decarbonisation solutions, right? And I'll also say, please do also join us for our next week's webinar, where we're going to peel it back another layer, where we're going to take perhaps some of these areas that Samuel touched on a little bit earlier, and actually look at how we can use technology and the insights that we get there to do some of these analysis as well. So I want to say thank you, everyone.